It's fun. We're gonna give this a go. You're rooting for me, right? Okay, so this one is denominator of 9. So I'm gonna go 0, negative 9 pi over 9, negative 18 pi over 9. And I'm going to make a little arrow showing I'm rotating in the negative direction. Okay, now if I'm going this way, where would the 5 be? Negative 5 be? Yeah, quadrant 3, like a little bit here. So half of 9 is 4.5. So it's going to be like just a little bit past this way. Okay, now I'm going to ignore the negatives and say, what's the difference between those two? You guys all see it? 4 pi over 9. Do you see that it's 4? You do? Okay. Okay, now I'm going to be smarter than yesterday. And I'm going to use my space appropriately that I gave myself. Okay, so my quadrant 1 angle will be the reference angle, which is 5 pi over 9. And now I pretend that I have positives here instead of negatives, and I'm rotating this way. So what's 180 minus 5 pi over 9? That doesn't make any sense. That doesn't make any sense. I put a 4. Okay, hold on. I didn't. I said it's the same as the reference angle, but then I put the problem there instead of the reference angle. Cool, cool. That's great. Is that how it's going to go? That's okay. Anyway, reference angle was 4 pi over 9. So that's what we should put here. And now we do 9 minus 4, which is 5. Okay, now we're going to do 180 plus the reference angle. And now we're going to do 360 minus. Whew. Why was that so challenging for me? Who knows? Okay, now when we do coterminals, go back to the original. And add 360 and subtract 360. So this will be 13 pi over 9, which makes sense because I already have that labeled there. And this will be negative 23 pi over 9 also. and infinite other things that I'm too lazy to find. Okay, when you're ready, find number 8. Okay. All right. Question 30, 60, 90 or 45, 45, 90? 30, 60, 90. You can tell from the scale, but you can also tell because there's a 6 in the denominator. Okay. Short side is 1/2. Hypotenuse is 1. Long side is √3/2. Okay, you're in quadrant 2, which means that x is negative and y is positive. And they want sine, which is the y, which is this one, which is 1/2. Oh, why couldn't all warm-ups be that quick? Oh, no. Don't care. Don't care. Okay, guys, now find number 12. And this one has got a little bit of a spicy nature. Can you tell? Okay, you're wondering, I'm hoping your brain is wondering what to do with this situation here. Okay, so I think you can tell A is -4 and B is 1/2. So I put a 1 in front of the theta and then this is 1/2. Okay, the period is 2 pi over 1/2. 2 pi over 1/2, keep change flip, is 4 pi. How many boxes is 4 pi on this graph paper? 8. Can you guys all tell that 4 pi is 8 boxes? You good? Sure. Okay, H, there's no parentheses, so that's 0. And K, there's nothing hanging off the end, so that's also 0. And if you want to, in your mind, you could, not in your mind, but on your paper, you could write -4 cosine 1/2 theta minus 0 plus 0. If your brain likes that better, you can rewrite it like that to see where I got all of the things. Okay, midline is 0. I'm not going to, why is the scale radians? That is not supposed to be like that. This is supposed to be for -4. See, here's the thing. There's this lady that makes these packets. She's really, really nice. She makes mistakes sometimes. She must have clicked radians on the y-axis. Really didn't mean to put radians on the y-axis. Anyway, do you know this lady? Super nice lady. She tries real hard, but that's life. Okay, anyway, so midline is 0, which is already bold, so I'm not going to draw that. Amplitude is 4. Miss Franco and I, we were at the staff meeting yesterday. We got into this really deep discussion about the difference between A and amplitude. You guys know that A and amplitude really are not the same thing. We kind of pretend that they're the same thing. A is -4 in this problem, but the amplitude is 4. Amplitude is like speed. It shouldn't have a direction associated with it. It's just height or distance. Anyway, doesn't matter. It's just being picky because we're, nerdy ladies. Okay, so next step, locator point for cosine is h comma k plus a. H comma k plus a is 0, -4. Does that make sense for this graph? Yes, because it's negative cosine, so it should start at the bottom. The period is 8 boxes away. 1, 2, 3, 4, 5, 6, 7, 8. And then cosine, negative cosine looks like this. I just graphed this dot and this dot. So in between those two, it's going to hit the top. In between the first two, it'll hit the midline. In between the last two, it'll hit the midline. Now we're done. Okay. Now can you guys look at the quiz review, please? Any questions that you have from the quiz review that you'd like me to go over? Six? Is it because of the start of pi over 4 or negative pi over 4? Okay, so do you see how this is pi over 2? Then halfway would be pi over 4. Is that might be all you needed? Okay, that's what I thought. So if you have half a sandwich and you cut that in half, you have a fourth of a sandwich, which is sad because you want the whole sandwich. Anything else about the quiz review besides that, which I anticipated? Great question. Yes, honey. Okay. Denise and Mike are planning trips to 13 countries this year. There are 15 countries they would like to visit. They are deciding which countries to skip. Does it say anything about them caring about the order of them or any of the countries being more important than the other? Okay, so that means it's a combination. And you have 15 total countries and 13 that they want to go see and 2 that they're going to skip no matter what. Does that make sense? Okay. So 15 factorial over 15 minus 13 factorial, 13 factorial. And that will be, the formula for that will be at the top of your quiz. You have to decide which one it is, but the formula is there. Okay, now let's talk about the mental math. So if I cancel out the 13 factorial, does it make sense that there's only 15 and 14 left on the top? Okay. And then on the bottom, there would be 2 times 1 time, no, just 2 times what? Does that make sense so far? Okay. Now what I'm going to do is I'm going to go cancel, cancel, and make that 7. And then I'm going to go 15 times 7. And then there's a bunch of different ways that I can do that. But my favorite way is to say 10 and 5 and 7. And then 70 plus 35 is 105. Does my area model make sense? I like that in a pinch, just in case I can't figure out the multiplication. And we discussed that captain and co-captain are different things according to these problems, right? Yes, honey. Okay, so 15 minus 13 is 2, and 2 factorial is 2 times 1. I probably should have showed my work, sorry. Here, I'll go like this. But does it make sense that I crossed out the 13 with the, okay, just checking. Those are excellent questions. Wonderful questions. Your class thanks you for going over those. Okay, now notebook time. I have something new and exciting and crazy looking to teach you. So, while you're setting this up, did anybody flip through the packet and see some crazy looking symbols? Yeah. Saw some crazy looking stuff in there. Okay, that's what I'm gonna teach you today, is those crazy looking symbols. And you're gonna feel really smart while you're doing it. It's not a big deal. It just looks really fancy. Um, but it's called summation notation. It's also called sigma notation, and it uses a capital sigma. So I'm just going to add this here because sometimes you'll hear summation notation and sometimes you'll hear sigma notation. And what in the world is this? Sigma notation, summation notation is literally people being lazy. It's shorthand. Mathematicians are too lazy to write out their series. Even the ones that are 5 numbers long, they don't want to write them out. Mathematicians are always looking for ways to be more efficient and be lazier. That's the whole point. So they came up with this shorthand system to represent a series without writing out all the numbers. If you only have 5 numbers, no big deal. But if you got a lot of numbers, it's shorthand to represent that series. Okay, and here's what you do. So you make a capital sigma, and good luck making your capital sigmas. I try to use the graph paper. That's not really what it looks like, but that's okay. You guys can see what they look like in your packet. Okay, so you make a capital sigma, and we're going to label that. That's capital sigma, and that means add up. That replaces all of the plus signs in your series. On the bottom of the sigma notation, you define a variable. Most of the time it's n. You're going to see k, you're going to see I, you're going to see m. Those are the most used ones. I use n because that's kind of how we write our stuff. And you start with the first term. Almost always in this class, we're going to start with 1. It doesn't have to start with 1. When you get to calculus, they're not going to start with 1. They're going to start with 0. But what this is saying is it's saying I'm starting at the first number here. And then you put the ending number at the top. So right now it's saying add up 5 numbers, starting with the first number to the 5th number. And this is your start. And this is your stop. Kind of like computer programming. It's like keep going to the next line, keep going to the next line, keep going to the next line until you get to 5, then you're done. Okay, now what goes here is the equation. And you can put the equation in terms of term 0 or term 1. I like to put term 0 because I'm lazy. So I'm going to go like this. I'm going to go like this. These are going up 4. Term 0 is 11. Okay, this picture, without all the arrows and labels, represents this series. These two things are equal to each other. And you're like, Mrs. Talbot, there was so much more work to make this thing than it was just to list those 5 numbers. Yeah, but imagine if you have 105 numbers. You don't want to write out 105 numbers. Nobody wants to do that. This is much easier. But the other part about it is great, is that now you have the equation, so you can find anything. Okay, so sum equals n over 2 first term plus last term. Okay, now pretend. So I'm going to take this here piece of Post-it note, and I'm going to pretend that I can't see that. And this was the problem given to me instead. I know there's 5 terms. So starting at the first term, ending at the 5th term, I know there's 5 terms. And I can get the first term by plugging in 1 into the equation. I can get the last term by plugging in 5 into the equation. So plug in the bottom thing, plug in the top thing. Okay, now does that make sense from what I have written up here? 5 numbers over 2, first number plus last number. Same math, right? And this is 2.5 times 46, which is 115. Anyone done any computer programming before? This is basically computer programming. The next column I'm going to relate computer programming a lot. at least old school computer programming. I want you guys to note that t squared is not arithmetic. Arithmetic has to look like mx plus b or m times n minus one plus p1, like it's not gonna have a square in it. How do you operate sigma notation when it's not arithmetic? It doesn't have to be arithmetic to be sigma notation. It can be any equation here, anything. Okay, so what I mean by computer programming is this is telling you where to start and this is telling you where to stop. So what this is saying is plug in 1 as the first thing, plug in 2, plug in 3, plug in 4. Where should I stop? 6. Plug in 5, plug in 6. There's no cute formula like Gauss's to add this up. You just have to add it up brute force style. So when you write code, at least it used to be, I don't know if it is anymore, you can tell me. You would give it like a route and then you tell it how many times to repeat and come back. And this is telling you, start with a 1, then go to 2, then go to 3, then go to 4, then go to 5, then stop at 6. Start here, go to here, including all of the whole numbers in between there. So it's like row 1, row 2, row 3, row 5, row 6. It's not really that, it's not that bad. Okay, now we're going to do number 53, which is a bunch of kind of mixed stuff with this business. So I'm going to give you time to set that all up. The good news is this is all we're doing, so this is the end, but okay, now I'm going to warn you. C is spicy. C is a foreshadowing problem. I do not want you to worry about C. We're going to come back to that, and it's going to make more sense later. But the rest of them are totally fine. Okay, here we go. So find the sum. First question I have for myself is this arithmetic? Yes. So can I use the Gauss formula? Yes, great, because I don't want to list out all the numbers. I'm too lazy. Sum equals, how many terms are there? 10. 10 over 2. First term is 13 times 1 minus 5, which is 8. Okay, now the last term, what term would that be? Term 10. So total number of terms divided by 2, plug in the bottom thing, plug in the top thing. Okay, B. This is not in sigma notation. Can tell that it's arithmetic though, just because that's what we're working on. Sum equals. How many terms are there in this problem? 23 over 2. First term plus last term. That problem is great. I love it. Okay, now C is really spicy. And it's foreshadowing for later. So just so you know, sum equals. Can you tell that it's arithmetic? It's going up by 6, right? Okay, sum equals n over 2. Do I know how many terms there are here? No. What's the first term? Not term 0. 4. Okay, and then here's the really hard question. What's the last term? 6n minus 2. Okay, so I combined those two guys. I'm going to do this in 2 steps. I'm going to divide both of those by 2 first and then distribute. And this one's really cool because it has a formula for the sum. So you could plug in any n that you wanted and get the sum without doing any work. Are they all like this? Yes. Not the same formula, but okay, just pause on that in your brain. And I'm going to come back to that at a later date. Okay, I want you guys to do this one. This one is like A. Give it a go. It's exactly the same thing as A. You got this. You could speak about it to each other. That'd be great. Be super awesome. Or not. It's fine too. How'd we do? Are you guys ready or no? Okay, don't look at the screen. Don't look. You looked. I'm not unfreezing it. That's what happens to me too, though. Every time someone says don't do this, and then I immediately like push the button like group. I can't help it. Just